Okay, in this video we want to take a look at the domain of rational functions. We're going to start by defining what a rational function is. And keep in mind that rational numbers are numbers that can be written as fractions, so that helps me recognize that a rational function is a fraction of polynomials. In other words, I have some polynomial p of x that is being divided by another polynomial q of x. Okay, so keeping that in mind, that it's a division problem, helps me think about the domain. I know that when I have a fraction, I can't let the denominator be 0 because that'd be like dividing by 0. So when I'm asked to find the domains of these things, I'm going to remind myself denominator can't be 0. Two examples here. The first one, I'm going to take this r of x equals 3x over 5x plus 7 and say, all right, 5x plus 7 can't be 0. Well, then if I subtract and divide, I recognize that x cannot be negative 7/5. So then I want to write the domain in a little bit more formal way. So I would do that by writing an interval, negative infinity to negative 7/5, and hop over that. That's why I'm using these parentheses. That endpoint is not included. Negative 7/5 to positive infinity. This next one is very similar. Okay, so what I have to do to solve this one is take x squared minus 2x plus 1 and say I don't want that to be 0. Now, since I have a quadratic, my strategy for solving this is trying to get that in factored form. There's nothing common, so I'm going to go right to my two parentheses, and I'm going to get an x minus 1 and an x minus 1. So I have one quick problem to solve. Oops, 0, which means x itself can't be equal to 1. All right, so that's the only restriction I have. So my domain is going to be negative infinity to 1 with parentheses, and then union 1 to positive infinity. And that's all we have to do to find the domain.